All right, let's continue looking at ionization energy with some sample questions. We'll start with a real easy one right here. Which is greater, the ionization energy, the first ionization energy of boron, or the first ionization energy of carbon? Well, you can cheat easily and just look in the book, and you can find out that boron's first ionization energy is 801, carbon's is 1086, and so carbon would have the larger ionization energy. But let's look a little bit closer, because in the last cast, or in the last video, we talked about watch your electron configuration, because that's the thing that describes or actually justifies why you can answer all of these questions about ionization energy. If you look at boron's electron configuration, 1s2, 2s2, 2p1, and then carbon's electron configuration, which is right next to it on the periodic table. Here's boron, here's carbon. It's 1s2, 2s2, 2p2. So if we take this electron away, which would be the one that's removed in the first ionization energy, we now have a pretty stable electron configuration left. 1s2, and then the 2s sublevel completely filled. A fairly stable configuration. Whereas in carbon, if we removed one electron right here, we'd still have one electron in the 2p orbital, not nearly as stable as the boron. And so that's why it would take less energy to remove this electron right here, because the stability would be greater after it's removed than carbon. So when it's kicked out, it's more stable with the 2s orbital full. All right, let's take a look at a second example problem. We'll zoom this back out, remove this question, and this time, which would you expect to be greater? The second ionization energy of boron or the second ionization energy of carbon? You remember this time, we just looked at the first ionization energy of boron, the first ionization energy of carbon, and it was really easy to look on here. But now, what about the second ionization energy? Well, as we said before, first look at the electron configurations. I'll give you a second to write those down. So when something loses or is ionized twice, second ionization energy, it would become a +2 ion. So I put +2 above both of those. These are the electron configurations before it lost any electrons. Carbon, once again, 1s2, 2s2, 2p2. Boron, 1s2, 2s2, 2p1. Now, when boron loses one electron, for the first ionization energy, this one would go away first. The second electron would have to come from here. And so one electron would have to be lost from here, and it'd end up as 2s1. Okay, that would be the second electron lost. Notice where it would be lost from. The 2s orbital, pretty close to the nucleus, pretty stable because s only has 2 electrons in it. Let's look at carbon. If carbon loses one electron, it becomes 2p1. Well, now if it loses a second electron, where would it lose it from? Well, it'd lose it from right here. And notice what's left, a pretty stable configuration right here. And so carbon would probably be okay with losing a second electron to become really stable, whereas boron, probably not nearly as stable after it loses that second electron. So, as a matter of fact, it's the opposite answer of last time. Boron would have a larger second ionization energy. Remember that 1s2, 2s2, 2p6, 3s2, this electron configuration always means that it's further from the nucleus, and that's why we want to take away these guys right here, because they're the furthest ones away from the nucleus. But now when we get closer, we're starting to remove these that are closer to the nucleus. Here we don't have to remove the electrons that are as close to the nucleus, and therefore it costs more energy to remove this second electron from boron than it does from carbon. So the second electron would need to be removed from the 2s orbital in boron. It's closer to the nucleus, and therefore it experiences a greater effective nuclear charge. then it would cost more energy, and so the second ionization energy would be greater for the element boron. Last thing in this video, we're going to take a look at some equations that are formed when ions are formed, when ionization energy occurs. So, if we had the first ionization energy of phosphorus, please write the equation. Okay? Phosphorus would then lose an electron, so phosphorus would become phosphorus plus 1, and we'd write the electron as a product because it's lost, or it's given off, or it's a product of the ionization energy of phosphorus. Let's see if you can do one. Please write the second ionization energy of calcium. Please write the second ionization energy of calcium. So, to be the second ionization energy, remember calcium would have first had to lose one electron. So you would start with calcium with a positive charge, because it would have already had to have lost one to be calcium plus 1, and we want the second removal. So the second removal would make it be calcium plus 2, and an electron that's lost. All right? Write the electron configuration before and after for each of these. So here's for calcium. Calcium would originally be right here on the periodic table. It would be like argon, and then we'd be in the fourth period, 4s2. So argon 4s2. After it lost an electron, then it would be argon 4s1, and after it loses a second electron, then it would be calcium, and this 4s2 that used to be here would be gone. And so its electron configuration would just be argon right here. We wouldn't have any of these electrons anymore. They would be gone. All right, so ionization energy is the loss of electrons. A lot of things govern how much energy it takes to remove an electron, and hopefully a few of these questions and a few of these equations enlighten you as to how electron configurations and stability can help you answer those questions.